typo on number 6A. Distributed as normal a mean x plus mean y. Should be a squared sigma squared x plus b squared.
Yeah. Yeah. Yeah, that's the good start to that. Yeah. So ax plus by, so it's right. The a would also get squared. So please change that to a squared. That plus b squared. That. Excellent. So that, yeah, that is a typo.
That was 6A, right?
Yeah, it's 6A. So the typo was here with a squared and then plus b squared. Yeah, good. All right. Okay, so let's get started. One. You got to work out what's the value of k?
3Fs, I think it was.
So all we have to check was did this, well, already you know that k must be something non-negative because you have k times x plus y squared and your density function has to be non-negative. And the other condition you check is that you integrate out over the whole r squared space, you get 1. So when you plug in kx squared plus y squared, integrate that, you get k equals
3Fs.
Okay, so I'm not going to double check that, but basically that's the condition. Expected value of x squared plus y squared. X squared plus y squared times the function. Density function is 3 over 2. X squared plus y squared, right? Oh, so then if I'm actually plugging that in, then I can only integrate from 0 to 1. X dy. So 3/2 x squared plus y squared squared, so that gives you x to the 4th plus y to the 4th plus 2x squared y squared. With respect to x first, you get x to the 5th, y to the 4th x, x cubed over 3y squared, equal to 1, 3y, 1, take that 1/5, y 4th, plus 2/3 y squared. If you want to integrate with respect to y, you get that to be y over 5, y 5th into 5, plus 2y cubed over 9, that is 0, 1, 1/5 plus 1/5 or 2/5 plus 2 9. What do you get this to be? 15, 28, 3. Is there any mistake? 15, 2, 14 out of 15. Okay. C. Probability that y is less than 1/2, condition on x less than 1/2. This is just probability that y. This is just practice problems, problem 1. Oh, and there's a typo in 6a. So in 6a, the variance should be a squared sigma x squared plus b squared sigma y squared. So probability that y is less than 1/2 and x is greater than 1/2 divided by the probability that x is greater than 1/2. So the numerator is you integrate y from 0 to 1/2, and you integrate x from 1/2 to 1, the density function, 3 halves x squared plus y squared dx dy. The denominator, you integrate y over everything. Your x is going to be integrated from 1/2. Does anyone have an answer for this?
4/11.
Did everyone get that? Or did at least one other person get that? Okay. 2 or 3. So basically, that's your calculation that you're going to do. D. Probability y equals to 2x. So if you think about it, you're going to integrate over the region y greater than 2x, right? This is what you're going to do. So you could say y goes from 0 to 1 and x goes from 0 to y over 2. So that's one way you can write it.
I'm sorry, what do you have written under the integrator?
Y greater than 2x.
Oh, 2x.
2x. So I write my x like this. So you can write as y goes from 0 to 1, and x then goes from 0 to, it has, 2x has to be less than y, so x has to be less than y over 2. So this would be the most straightforward way to write this. Now, if you had written it as, let's say x goes from 0 to 1, and y goes from, so y has to be less than 2x. So what would be the problem with this? Yeah, so your y cannot be larger than 1. I mean, you can write this and still correct, but if you replace it with the density function, when y is greater than 1, the density function is 0. And so you can't integrate from x going from 1/2 to 1, because then your y would be over 1, right? So it's better to write it this way. If you write it like this, then your x only goes from 0 to 1. And the best way to see what's happening is, let's draw a picture.
I have a question here.
Yeah.
Is it double integral here for the bottom one? The
Yeah,
bottom one?
double integral, or if you want, you can first integrate out the y and find the density function just for x. So you could have done that separately, like as a separate step. So that inner integral, dy dx. This inner integral you could have done separately first. First try to calculate this density function for y by integrating y goes from, for x, integrating out this. You could have done this first, and then in here just put the integral x going from 1/2 to 1, the density function for x. So you could have written this instead. First find the density function just for x, and integrate the density function for x from 1/2 to 1. Or I just did it on one step, wrote it as one step. Basically the condition is on x has to be greater than 1/2. So I'm just integrating x going from 1/2 to 1, my y can take everything else.
Dr. Kumar? For that problem over there, couldn't you have, the second way, couldn't you have gone from 2x to 1 if you took dx cross section? Bottom.
Say that again.
So instead from y equals 0 to 2x, couldn't we have gone from 2x to 1?
Oh yeah, actually I meant to explain that one. It was y greater than 2x, right? Yeah. So actually I meant this. Yeah.
And you said that's not good?
Yeah, the earlier one was not right. It's this one.
Okay.
If y is greater than 2x. So let me just draw a picture of this. So let's draw the boundary value y equals 2x is So we are integrating over the region y greater than, this should be around 1/2, okay? We're integrating over this region. Y is, so this is y equal to 2x. Y greater than 2x is everything above this line, right? And I only look at the region above this line and in that square, so that's just this region. So either I can say y goes from 0 to 1, and at any point here, my x goes from 0 to y over 2, okay? So for any y, as y goes from 0 to 1, my x would go from 0 to this point on this line, and this line is y equals 2x or x equals y over 2. So that's the first way. Or I could say x goes from 0 to, what is the point of intersection here? It's 1/2, 1. So x goes from 0 to 1/2, and then for each x, I go from y equals 2x to 1. Okay? So if I write like this, I'm thinking of it, x goes from 0 to 1/2, and for each x here, I go my y goes from here to there. Okay? So that's the second way. So either of these two should give you the same answer. Let's just pick one of the ways. I go this way. X goes from 0 to 1/2. 0 to 2, I need to give respect to y first, so I get x squared y, is y cubed over 3, y equals 2x, 1. Actually, this way might be easier, the simpler numbers to plug in. Let's take this way. 1/2. You know what, I'm going to integrate that, it's easier. Okay, but you know you can even do it the other way. Let's do this. So integrate respect to x, 1 equals 0 to 1. Integrate respect to x cubed over 2, x cubed over 3, plus xy squared. The value from x goes 0 to y over 2. Let's plug in, you get y cubed, 2 cubes, 8, 24, plus y cubed over 2. And when I plug in x equals 0, that's it. What do I get? 3/2. And I integrate this, I get y over 4 times 4, 4, 8, 0, 1. So 1 over 4 times 4 is 1 over 8, 6, 3, 4, 2. I get 1 plus 12, 13, 3, 8 times 24. What's 8 times 24? What is it? 2 is a 6.
192.
2, 9, 39 over 192.
That can simplify it to, there's a 3 over 3 in there.
Yeah, I can simplify it 13 divided by 64.
Oh, there was, actually, I should have done that first. So 64. Like 13 over 64. Right. Okay, so that's the answer to 1D. 1e. So we're integrating over the region where x plus y is between 1/2 and 3/2. That's what we're doing. To get the limits of integration, again, it's best to just go to a picture and you see that. So x plus y is greater than 1/2, which means y is greater than negative x plus 1/2, and x plus y less than 3/2 means y is less than negative x plus 3/2. So your boundary lines are y equals negative x plus 1/2 and y equals negative x plus 3/2. So we're looking at y has to be greater than negative x plus 1/2, y is less than negative x plus 3/2. So we draw this picture, y equals negative x plus 1/2, when x is 0, you get 1/2 here, when y is 0, you get x is 1/2. So this is the line y equals negative x plus 1/2. And then your line y equals negative x plus 3/2 is just the same line shifted up by 1. And this region. So you want y between these two lines, right? Y greater than negative x plus 1/2 and less than negative x plus 3/2. So what is the region of this strip between overlapping with the triangle? Is this region, right? So if you want to integrate over that region, what is this point of intersection? We see the point of intersection when y is 1. What is your x value here? When y is 1, your x equals 1/2. So,
I have a question about the way you do it.
yeah.
You're saying x is less than y over 2?
X is less than y over 2, yeah.
So why is y over to the top bound?
X is less than y over 2. So x goes from 0 to y over 2.
X is less than something? Or less?
Yeah. Y is greater than 2x. I'm interpreting it as x is less than y over 2. Okay? So x goes all the way from 0. The largest value you can take is y over 2.
Can we do it the other way?
Yeah, the other way then would be y is greater than 2x. So y goes from 2x to 1. This is the other way. So you can either write it like this or like this. In both cases, all you're doing is integrating over this shaded region.
And which one is that one that says x goes from 0?
0 to 1/2,
Okay.
and then y goes from 2x to 1. When we write on this region, so actually this point should be just above this. So this is x 1/2 comma 1. This 1/2 comma 0. So as x goes from 0 to 1/2, your y goes from this line to the point y equals 1. As x goes from 1/2 to 1, your y goes from 0 to the top line. So you split this up into 2. So as x goes from 0 to 1/2, your shaded region y is going from this line, which is y equals negative x plus 1/2, all the way to 1. It's not going to the top line, because the top line is outside that shaded region. That's this function. And then as x goes from 1/2 to 1, your y goes from y equals 0 to the top line, which is negative x plus 3/2. Okay, let's do the first integral. So first integral, you get 3 over 2 integrated with respect to y first, x square y plus y cubed over 3, evaluated from negative x plus 1/2 to easier to do. No, negative x plus 1/2 to 1. So let's plug that in. X goes from 0. So you plug in 1, you get x squared plus 1/3 minus, you plug in negative x plus 1/2, you get x squared negative x plus 1/2. Okay, at this point I'm just going to stop and say I'm not going to give you anything this complicated. I mean, it's not complicated, it's just tedious, and for an exam I'm not going to give you something to calculate. But good exercise if you want to brush up on your calculus.
Would it have been easier just to say 1 minus the white space? You wouldn't have to.
Let's see, the white space, actually the white space could, no, but the thing is, it's not,
1 minus, it's
Oh, yeah.
subtracting that.
Yeah, 1 minus.
yeah, it would be 1 minus that.
Mm-hmm.
1 minus.
Oh,
you still have to
oh,
consider
the
this
unshaded
region.
space.
It's roughly equivalent.
It seems like it'd be about the same.
And one of the integrals is nicer because you get zeros. You know.
Right, so yeah, actually that, you could be right, that would be a better way to do it. Because we just want integral of the density function in this strip, and the integral of the density function of the whole rectangle is 1. So yeah, 1 minus that would be a good idea.
Okay, and then you could just use the bounds 1/2 and 0, right?
Then it's, well, okay, it won't be that simple because you have, as x goes from 0 to 1/2, you will have y going from 0, but you will still have this as an upper bound,
Right.
right? So
Okay.
you will have like one complicated function, but not too bad.
It's the same thing, but it's, yeah.
But it's a little simpler, maybe.
I think one of them's easier and one of them's not. Like,
Yeah, but in both of them,
They
you will
both are not
still
easy.
have this appearing as one of the bounds, and
Okay.
this appearing as the other bound, so it may not be that much simpler. And the other thing would be, as x goes from 1/2 to 1, y goes from this bound, so that's going to be the ugly part, but then you plug in 1 for that. So maybe it's not necessarily that much simpler when you do the calculations. Yeah.
But it would be equivalent.
It would be equivalent. And remember, it's only because you know that the integral over the square was 1. Okay? And that's the only reason why it's equivalent.